Hello and welcome back to Calculus 1 for one last time. I know. Time flies when you're having fun, right? Tonight is the final lesson. This is the part 2, the revenge of U substitution. We are going to take a look at the definite integrals that are done with the U sub. We'll talk a little bit about what's needed to survive Calc 2, like a survivor's guide, the way to ruin your winter break, and get ready for Calc 2, obviously. Talk about the final and disappear into the night. Final is next week at some point in the day. It was 5:30. Thank you. I'll show up in this room. So I'll see you then. And yeah, it's 5:30. And don't forget your projects. Don't forget anything you want to hand in is due that day. Your online homework will stay open till midnight to fill in any of the 0 sections you might have. You are not allowed to have 0 on any of the homework percents. So just make sure they are non-zeros. I mean, preferably you should have homework 100 on each section, but...
When did you say it was closing? Midnight?
At midnight. Yeah, you have a week and about 6 hours.
Do you open the quizzes tomorrow? Do we have quizzes for the final?
No.
What were the last 4 things on the homework? They weren't quizzes. Was it like review sections or something like that? No. On the homework, when I went on there, there's all the sections, and then there's like 4. They weren't quizzes, but it was like there's a 1, 2, 3, 4. I don't know if it's sections. Oh, I don't know. It just like pops up on there.
Ignore it. So let's talk about U sub. Last time we said that you might run into an integral which you have to solve using the U substitution. For instance, the case you see on the screen right now would be one of those cases. So we set denominator e to the 2x plus 1 to be u. du is going to be 2e to the 2x dx. We see that we need this 2, so we fix that. And now we have 1/2 integral of du over u. And that is what? Very good. Plus c at the end. And then we plug back our e to the 2x plus 1. And then plus c. And we call it a day. So this is what we did last time. And the goal for today is to do the U substitution with limits. Now, before we do that, I will just remind you that the definite integral, which we used to write a over b f of x dx, is actually x1 to x2 f of x dx. Because you are on the interval which you are integrating over is a to b is your x1 and your x2 on the x-axis. So if you are switching, transforming integral from x domain to u domain, you will have to swap these limits to u domain as well. Now there are 2 ways to deal with this. You can either leave them as x, do the u sub, and then go back into x and use the given limits, or, which is faster, transform your x limits into u limits, and then you don't have to go back to x. You can just compute in u and you're done. So let's take a look at this introductory vanilla problem 45. So we have 0 to pi over 8 of cosine 2x dx. Now, please circle, box, and check and star this problem, because you will be integrating this a lot in your Calc 2 class. So now what do we have? We do, well, you will memorize the answer to this. You already know what it is, but let's do it step by step. So u equals 2x, du equals 2 dx, and I see that I have to put this 2 in to make all of this work. And now, here is the new stuff. There we go. Oh, thank you. I feel much better now. Yep. Yes. It's manifested differently though. So your u1 will be 2 times x1, because that has to be from the formula up there. So that's 2 times 0, which is 0. So for my new integral, the bottom limit stays 0. u2, upper limit, is going to be 2x2, and that's going to be 2 times pi over 8, which is pi over 4. So the top limit is pi over 4. So now we have 1/2. Integral of cosine of u is sine u. And the great thing is that since I switched the limits, I don't have to go back to x. I can just stick to u variable. And this is 1/2 sine pi over 4 minus sine of 0, which is 0 anyway. No plus c this time, which is 1/2 times root 2 over 2, which is root 2 over 4. Sine of 0 is 0, so that's gone. There we go. So what we did is we started with the integral, we did the u sub, and what's new? New is the stuff in orange over here. We used our substitution equation to transform limits from x's to u's. And because we transformed the limits, these are the u limits. Which means if the function is in terms of u and limits are in terms of u, well, just plug in and you're done. Next example. -1 to 2, x squared a to the x cubed plus 1 dx. Do it. What's u?
X cubed plus 1.
Good. What's du?
3x squared.
Keep talking.
What's next?
dx. Good.
Yeah, that's right.
That's what you meant. And then we have a 3 and a 1/3 in front to fix the issue. So now I have 1/3 integral of e to the u du. Perfect. Let's go. New. Change the limits. u1 is going to be -1 cubed plus 1, which is 0. Are we all cool on that? The 0 on the bottom? u2 is the upper limit, which is going to be 2 cubed plus 1, which is 9. So this is equal to 1/3 e to the u from 0 to 9, which is 1/3 e to the 9 minus e to the 0, which is 1/3 e to the 9 minus 1. There's no plus c because it's a definite integral. And wait, what happened? One at a time.
No, you do. Why is it just 9? 9 cubed plus 1.
The new limits are 0 and 9 when you change
Oh, I
them.
see what you mean. Yeah.
So now we plug that into u because we have u limits. -1 and -2 are x limits, right? Yes.
The integral of a to the u isn't it equal to e to the u over u?
Since when is integral e to dx? E to dx over x.
Yes, so integral of
Is it? Integral of e to dx is just e to dx. Integral of e to the u is just e to the u. Integral of e to the y is just e to the y. Nothing there. U is now our main variable. Student. What happened? Plus C. No plus C. Definite integrals have no plus C. Right?
definite.
This is e to the 9 is a number. Right? There's no functions here. You're gonna love this one. E to the w cosine e to the w dw ln of pi over 4 to ln to pi over 2.
Wow.
I know, right? No pressure, you have 18 seconds. Go. Yes. Now you're putting me in a difficult situation to say no. No, this is what I take. Good evening.
Good evening.
You didn't have the accent. All right, let's take a look at this. Let's take a look at this problem.
Wait, now you have to let him answer. They don't like mute the phone. This is calculus.
This is calculus. Do we all have e to the w? We do? Good. du is also e to the w dw. Lower limit u1 is going to be e raised to the ln of pi over 4, which is pi over 4. The upper limit, e to the ln of pi over 2, they cancel again, pi over 2. Great. So, the lower limit pi over 4, upper limit pi over 2. Cosine u du. Easy peasy. Sine u, pi over 4 to pi over 2. So we have sine pi over 4 minus sine pi over 2. Sine pi over 4 is? Very good. Minus sine pi over 2 is? Excellent.
Isn't it pi over sine of pi over 2 minus sine?
Oh, yes. I was just testing you all. And you just passed the test. I just heard don't put this on the final. That's all I heard. You can also write this as root 2. Like, you can write it this way as well. It doesn't matter. Both are fine. All right, one more, and we are done with U sub. Then you have Calc 2 to practice this pretty much every problem. So, yes, there was a lot of enthusiasm. Yeah. Yeah, this is a nice problem. 1/3 to 1 over root 3. 4 over 9x squared plus 1 dx. Good luck. What's the secret? Arctangent. If you remember last class, this is arctangent. So, what's u? 3x squared. Well, I mean 3x, yeah. Calculus 1.
Can you do it the other way?
So u is 3x, du is 3dx, and then you go from there. So u1 is 1, and u2 is 3 over root 3. Then you rationalize root 3, and you get root 3. So you can kick 4 in front of the integral. You have your limits 1 to root 3, and you have your 1 over u squared plus 1 du. This is 4 inverse tangent of u computed from 1 to root 3, 4 times tangent inverse of root 3 minus tangent inverse 1, 4 times inverse tangent of root 3 is very good. And then inverse tangent of 1 is excellent. The square is only applied to x, not to 9. And if I'm going to make the whole thing squared, I have to have 3x everything squared, right? This is 4 times pi over 12 for a total of pi over 3. Do we all have pi over 3? No? Good, fix it. Oh, I forgot a 3. Why don't you say so? There we go. That's going to be over 3 everywhere. So that's a 9. Better? Good. So imagine me taking the finals. I can.
If you want to take it full, you get the inverse tangents from the unit circle.
Sorry?
You get the inverse tangents from the unit circle.
Me? I just know them.
How?
But yes.
Yeah, we would.
That's what I learned it for the first time, yes. For those of you Going to Calc2 because this is a good time to talk about values of trig functions. Let's quickly take a look at one thing, and then we'll take a look at Calc2 as your future. Try to remember this chart. It's very easy to learn all of these values if you know some basics. Look at this. You have your sines, your cosines, and your tangents. Now I need you to look, not write, because if you're looking, it will be clear and you will catch up and it will make sense. So, and this is also on the stream, so you can always go back and take a look. So just don't write, see it. What are the angles that we are using? 0, 30, 45, 60, and 90, right? Those are the main ones. Now look how easy it is. I'm going to put this in red. 0, 1, 2, 3, 4. That's all I did. 0, 1, 2, 3, 4. Divide everywhere by 4. And then square root all of them. It gives you sine values immediately. So, if you put them in the order 0, 30, 45, 60, and 90, all you need to do is 0, 1, 2, 3, 4, divide by 4, square root. And then you compute these values. 0 divided by 4 is 0, square root of 0 is 0. 1/2, root 2 over 2, root 3 over 2, and 1. For cosine, write the same numbers backwards. 0, 1/2, root 2 over 2 must match, root 3 over 2, and 1. Tangent is sine divided by cosine. Divide them downwards. 0 divided by 1, 0. 1/2 and 1/2 cancel. 1 over root 3. Some of you like this rationalized. Root 3 over 3. Great. Root 2 divided by itself, 1. This one is root 3, and this is undefined because you can't divide by 0. There are all the values. All you needed to remember is 0, 1, 2, 3, 4 divided by 4 root. For cosine, write them backwards. For tangent, divide them where they stand. And you have all of your values for the first quadrant. So now, what is the secant of pi over 3? Well, secant of pi over 3 is 60 degrees. So, secant is 1 over cosine of 60 degrees. Cosine of 60 degrees is 1/2, so it's 2. You get anything like this. Bueno? Bye.